Hey, good morning, good afternoon, good evening out there, chat room, wherever you might be. Welcome back to the live stream. My name is Jeff Fritz, and we have a guest today. Today is, what day is today? I don't even remember what day today is. Today is October 29th, 2019, and we're going to write a little code today with my guest here. This is Tom Bates from Actian. Hey, Tom, good morning.
Good morning, Jeffrey.
It's so good to see you. My gosh, it's the end of October. I don't know about you. But it all of a sudden the weather turned for a chill here where I am in the Northeast, and I'm like, okay, what happened? We left summer immediately, and now we skipped right through fall, and it's like winter is here, you know?
Yeah, same here.
Oh my gosh. I'm looking at the chat room. We've got a bunch of friends already tuned in. I see some friends from the UK, from Germany. I see even. Who is that? Encoding is here from Chile. Welcome. It's so good to see you, my friends. Thank you so much for tuning in. Tom, why don't you tell folks a little bit about what you do at Actian?
Okay, so I'm a software engineer at Actian, and I work on one of our products, and it's called Actian Zen, and it's an embedded database.
Cool. So when we think about an embedded database, right, some of the things that we typically do here on my channel is we build websites. But Actian Zen doesn't embed in just, right, when I think embedded, I think I'm putting it into a small device, an IoT device, that set-top box that I might have that's running like a Roku type device, that type of thing. But you can embed it not just in that, can you?
That's right, and it is kind of a strange term. We mean embedded in that often you don't see it. So if you bought an accounting package from somebody, that accounting firm probably doesn't want to do a lot of database coding, right? They're more
Sure.
concerned with accounting rules. So they would purchase a database embedded in their software and use it, but the end user would never even know about us. But sometimes that's what we mean by embedded.
Oh, that's so cool. Okay, so now I'm thinking embedded database means more along the lines of something that I don't necessarily need a database administrator to manage.
That's perfect. Yeah.
Oh my gosh. Okay. So, hey, chat room, let's take a look. A couple more folks are chiming in here. Costa Rica, I've got Selva Salapan is joining us from India. Oh my gosh. And I love seeing all the folks tuning in from all over the place. Thank you so much, everybody. And I do want to let you know, chat room, because we have a guest today, I've turned off point redemptions, and I've also turned off some of the alerts so that we're going to give appropriate time here to Tom, and so we can focus on learning a little bit more about Zen database. So I mentioned that we build websites typically, or mobile apps here, but right, if I think about the DBA-less application, okay, sure, that means like a set-top box, or maybe even a mobile phone.
Sure.
Okay.
Anywhere you would need a database, but you either don't want to, or it just wouldn't be practical to have a DBA.
Oh, okay, that makes more sense to me now. Not practical. So but there are ways that you could scale, right? You could get to the cloud with this, right?
Absolutely. We run anything from a medium-sized server down to a phone or even an IoT device.
Oh, very cool. Now, do you have some information about the Zen database that we can take a look at here that you're sharing on your screen?
Well, I just have our website here. I think it'd probably be better if I just spoke to it.
Sure.
Zen is we like to think of it as a clever name for the database, and it stands for Zero DBA Embeddable Nano-Sized Footprint.
Okay.
And so by nano, we really just mean small, right? So
sure.
when people think of fully capable databases, they don't think of something that can fit in, say, 6 meg of RAM.
Right?
Yeah, so,
that's in today's world. That's tiny.
It is. It is.
Duke Twitch in the chat room is asking, is it like SQLite?
Well, it is, but it's more. So SQLite is a great product. It's been around a long time.
Sure.
And it kind of grew up from the single program, single threaded kind of approach, right? Mm-hmm. Whereas Zen came down from being a fully capable database, and it has kind of, how do I want to say this? The hardware has grown, but the database size has stayed the same. So what's ended up happening is a really fortunate thing. So we've got this fully capable database that now fits very well on small devices. And that's where we have an advantage over SQLite, because since we came from being a fully capable database, we have ACID, we have multi-thread awareness, transactions, all client server, all those things that SQLite is lacking.
Nice. So where other database services, and I'm looking at you, Oracle, have taken on bloat and size and become gigantic, and you need a cloud. The correct answer for the amount of memory you need to install Oracle or SQL Server or DB2 is more. You can never have enough memory for those. Zen has stayed nice and tight. That's great.
Yes, that's exactly right. And that's by intention.
Nice, right? There's definitely something to be said about that. Morzell is saying, it's always fun to hear talk about databases with a person who has seen databases with more than 10 records. Yes, absolutely, Morzell. We always want to have databases that have more than 10 records. Dear Lord. Right, we don't like a serverless database. We actually want to have something that grows and has a good size here. Nice. Folks chiming in now from Warsaw. Very cool. Thank you for tuning in. So, okay, we've kept it the same. You've kept the Zen database at the same size. So, I mean, small devices. How IoT a device are we talking about? Are we talking about a Raspberry Pi? Or are we talking about something even smaller?
Well, we do have a version that runs on the Raspberry Pi
Okay.
very well, because the Raspberry Pi is really just a little Linux box, right? And we've been
Sure.
running on Linux for over a decade easily, probably two
Nice.
decades. I just brought up on my screen something I brought with me today, which is a Jetson 2,
All right.
Jetson TX2, which
Let me
is
cut over there. There we go.
which we can describe as an IoT device, but it's very powerful and
Oh my
runs
gosh.
Ubuntu.
Okay. So hang on.
So our software runs very well on it.
Okay. So this is a little IoT, just a board with a couple cables off of it.
Hmm.
Okay. Exposes hardware capabilities, interfaces on the developer board, SDK that includes the BSP libraries for deep learning, computer vision, GPU computing. Oh my gosh.
Yeah, so
Okay.
we got into this board because we have a customer that we're talking with that wants to do edge devices that can do facial recognition. So this was a really great board for them because of the fact that it has the NVIDIA GPUs on it.
Oh yeah.
So it can do TensorFlow and all those sort of things. And they were interested in us because they were going to be storing and retrieving lots of data, TensorFlow models. They needed the transactional security. They needed the client server. And they found that some of the other databases, like SQLite, weren't up to the task. And then some of the other ones that were just simply too large and too expensive to put on all these edge devices. So that's where we came in.
So how much RAM is on this device?
16 meg, I believe. 16 gig, I believe, by default.
Okay.
The developer kit comes that way. They have different versions that you can tune that whichever way you want.
But in 16 gig, in a tiny little processor on this thing, you're able to run the database, facial recognition, handle a camera, all that stuff?
Yes, yeah, and I have a demo that shows that if we'd like to see that.
Sure. Now you've got me thinking, Tom. You've got me thinking. This would be a cool thing to turn into almost like an IoT doorbell, right? With a button and a camera that's pointing out. There might be a commercial product that does something like this, but I want to do the actual facial recognition, so I recognize the UPS guy that walks up, right?
Sure, and that's exactly what this customer's considering, because they think the IP is in having the best facial recognition software, for example. Right? So they need that IP protected. And so one of the advantages they get from using a database like ours is everything's is encrypted, whether it's persisted on disk, it's in memory, it's going across the wire, it's all encrypted, and that gave them a comfort level that they wouldn't lose their IP, right?
Sure. Okay, that makes perfect sense. That intellectual property, you want to protect it. You want to make sure that it stays with you, and nobody can lift it. Veronica Heck says not just facial recognition, or maybe recognizing the UPS, the FedEx badge, whatever. Holy crow!
Sure. So this is me, and this is a Python script.
Okay.
Doing very simple. It doesn't know that it's Tom, but it does know there's a face here.
Okay.
And in a more complicated, a more deeper TensorFlow sort of analysis, it might know it's me, or it might send it up to the cloud and say, I don't know who this is, and do more work up in the cloud.
Sure. Do further analysis, match against a set of known individuals, that type of thing.
Right. Like we don't ever let Tom in. So, we'd make sure I'm not.
Oh my gosh. Okay. So this is a Python script that's taking pictures and feeding it into the Zen database?
Yes. And I can show that. So instead of, I mentioned that we're client server as well. So what I'm going to bring up is we have a web browser interface to this machine. And we have a kind of a dashboard that goes with that.
Oh,
and
wow.
I just want to apologize ahead of time. I wrote this, and I'm not a web designer. So
no. Let me turn off the cameras here so we can see the little bit of the screen there at the bottom. Okay. So
what we're looking at here is the one on the left is kind of the same feed that we were seeing before locally on the Jetson.
Okay.
And the screen on the right is the latest positive. So if I move out of frame here,
it stops recognizing and recording.
right? We're still recording, but the last positive is, oh, look.
Because of the...
I made it look just like a face. And then I'll just pause it here.
So it's taking pictures from the webcam and just saving it into the database, doing the analysis on those pictures as they arrive in the database?
Well, almost. So down here on the bottom here, I've got the images, which is the images table or file.
Okay.
And every image is being written into that. So if I click on one of these here, we can see a little bit of metadata about at the time it was taken. We're doing facial recognition using a method called Cascades. It's been around a long time. It was open source, and that's why I chose it. Then we got a little bit of just a little bit of information. This is just an example of the kind of thing you can do with a database, is you can throw some metadata in there with the image instead of just storing the image.
Okay.
And then I can look at that particular image. And so that's one database table that's being written to, and every frame's being written to that. Then over here at positive images, the exact same thing, but as you would imagine, we're only writing in the positive images. And then here is the cascades, and this is what I was talking about, the IP. So we'll look at one of these. These are the models that are used. Now there's TensorFlow and there's other approaches, and as I mentioned, for this one we just used cascades. And this is what a cascade model looks like. So when I talked about the IP, you might spend, as a company, you might spend a lot of time developing a very powerful model. And it might look like a cascade. It might look something like this. And this is the kind of IP you're trying to protect.
Sure.
And we can change models. So like if we look over here, this is the status of the camera program. And once again, this status is being kept in a database table as well. So the camera program's writing its status occasionally, and then this JavaScript is calling into the server that's running on the Jetson in Apache and doing PHP to access that database and pull this information out as JSON. So we can see that we're running this particular cascade recognizer.
Okay, so I'm just trying to put all the pieces together. So
yeah, that was a lot.
So Python script that's taking the feed from the camera, doing the recognition, saving images into the images table.
Mm-hmm.
And then you have the PHP script that's looking at doing the cascade and showing you the positive images here on screen.
Well, I'll try it again. I kind of dumped on you a little fast there. So the camera script in Python is writing to the images table. Then it's also doing image analysis. It's doing facial recognition on that same image.
Okay.
And if that image is positive, then it throws it in the positive images table as well. And when it does the image recognition, it's using one of the cascades here, whichever one we tell it to use, to do that image recognition.
That makes sense to me now. Okay.
Okay, and then the only thing that's happening on the web browser on the PHP side is this JavaScript is using PHP to query into those tables and get a list to get the latest image, to get the latest positive image. So these are all database accesses using PHP. So one of the things that's nice about Zen is we support many, many languages interfacing to the database. So you don't have to feel constrained to just using, say, C++ or just using Python.
Right, and I saw that there's also providers, of course, for .Net Standard. If folks want to be able to use UWP, you want to use .Net Core, you want to use any of the .Nets, you can program and interface with the Zen database.
Yeah, we just recently released a C# interface, and so depending on how you're doing things, you can use managed or unmanaged code, and that we're pretty excited about that C# interface.
Oh, I'm a guy named C# Fritz. Of course, I like that. It's terrific. It's amazing.
I wondered if that was your middle name, but now
yes, it is. Yes. No, I can't back that up. I can't. All right, so this is really cool. You've got it writing into little database running on chip on the IoT device. But I mean, how many people are building things that are right internal to to a small device like that. And actually, can you show us what any of that code looks like? That the Python code that writes into the database?
Sure. And what we'll find is, and one of the things that we really like is that the majority of the work isn't the database, which is how it should be, right?
Yeah.
The hard part should be the cool stuff, which is the image recognition and that sort of thing. And we want to keep the database work to a minimum.
Right. Let me spend my time working on the business logic and less time thinking about CRUD operations, the create, read, update, and delete in the database. Make that as easy as possible.
I don't want to fuss with synchronization, writing my data. I don't want to fuss with file format, writing my data. I just want to work on the cool stuff, whether that be accounting rules or video capture, things like that.
Sure.
So this is the Python script, and I gleaned almost all of this from Google searches. And so if anybody wants to go play with this, whether they're going to use our product or not, it's pretty fun stuff. Grab yourself an old USB webcam, throw it on a USB port, and knock yourself out. It's pretty fun stuff.
Wait a sec. Somebody did searches and found the results and just dumped them into an application? Wow. I can't believe that. What developer would do that? Yes, we all do that, friends in the chat room. You need help finding things. You search for it, you find results. You're in good company when you search and reuse code. Okay.
All right. So this is a very, I don't know, what are we looking at here? We're looking at 300 lines, 400 lines.
Nice.
That does everything. This is just one huge Python script that does everything. And just quickly running through this, we capture the video. That's what we're doing here, this video capture. And we get some width and height data. We'll talk about why we do that if we want. And then we just loop forever. And to do the image recognition, we convert it to gray. We equalize the histogram. We're just trying to increase the contrast.
Sure.
And then we run the classifier. So that's that thing I was talking about. And this is all OpenCV based. OpenCV is been around a while. It's open source. You can get all kinds of help on that in the various blogs. And that number it returns, it sounds fancy, but it's really, in this case, since we're running a facial recognition cascade, it's the number of faces. They have cat face recognitions. They have all kinds of things you can find out there. It's pretty funny.
Cats? Really?
Yeah.
Okay.
You can do cat frontal, cat profile. I don't know how somebody came up. I guess, how do you get a cat to stay like that long? Anyway.
Well, I saw somebody it wrote a thing where they had a camera pointed inside the porch. So when a cat walked through the cat door, they could recognize if it was a cat because of the profile walking through, or if it was a raccoon or something else. Like, that's interesting.
See, that'll teach me to just be flippant, right? That there's obviously a very good reason for cat profile.
Very good reason. All right.
This is just using OpenCV to draw the images. And then I showed you that metadata, that JSON metadata. So Python's really good about handling JSON. So we're creating some JSON. That's the timestamp and so on and so forth. And you'll notice that I've talked about 10, 12, 15 lines here. I haven't talked about the database yet.
Sure. At this point, you're still formatting the data and doing the facial recognition stuff.
Exactly. And here we go right here. So we're going to store the JSON into the database. These are little Python functions we can look at if we want. And then here's store the image. I mentioned that positive images are the ones that get stored in the positive images collection. Well, here you go. So if we detected more than one, any faces at all, then we write it here and we show it. So and we just loop this forever. Sure. So I just want to stress again that the difficulty or the challenge or the cool stuff here is what do I want to detect? How do I want to detect it? What kind of cool stuff do I want to present to the user? Mm-hmm. Our goal here at Zen is to make the database manipulation part of that just as trivial and simple as possible.
Sure. It makes perfect sense. But I mean, this is Python script. Can you dig in and show us some of the syntax of the store JSON method there?
Sure,
right? Because clearly you're handing over to another function, and we want to go take a look at what that's doing.
So here it is, and here's where we finally get into some Zen directly. So we've got this thing called a collection, which it's a wrapper around a table.
Sure.
So you can think of it as a table.
We have collections in
Mongo.
Mongo.
Update, which is a wrapper around what you can think of as a record.
Okay.
So here we're just storing JSON. So we say document update, and then that's that JSON that we saw getting built up a little bit ago. And then what this code's doing is it's saying if I want to write document update document 1, because that's these documents, these photos are just indexed 1 through whatever.
Sure.
That's the way I design the table. If it's not there, I'm trying to update it. If it's not there, then I create it. So here's the create call. And that's it. That's the whole shoot match as far as storing JSON.
Nice.
And storing an image, we'll go down here while we're here. It's a little more complicated. In the case of JSON, I'm overriding the same record. And that call is used, you may recall that there was the status that was being updated in the bottom right-hand corner.
Yeah, whether or not it was a face or not, and whether or not it was connected.
Time and if we looked at it more, we would have seen megabytes written, things like that.
Okay.
That always gets written to the same record, so that's why always gets written to record 1. In the case of the blobs or the images, we create the document, same call. We're putting some JSON in there. That was some metadata about the document, the timestamp, and the kind of image, whether it's JPEG or PNG or whatever. And then the blob, which is the actual image.
Right, the bits of the image that you're loading.
Right. So that is the entire difficulty in writing to the database, is that call right there. Right?
Love it. Love how simple it is. Oh my gosh.
In this script, we're limiting the number of images kept locally because we don't want to fill up the local storage.
Sure.
And so that's all this next check is doing, is saying if we've gotten past the max images, then we're going to delete the oldest image. And so there's a delete call. And
just
then
roll it.
Yep, and then we're done. So and this is all thread safe. This is all transactional.
Nice.
So if I wrote this Python script to be using Python threads, I don't have to get into the business of doing any kind of synchronization myself. It all just works.
So the chat room is pointing out about this time last year, I wrote a little thing, and it's about that time for me to break it back out again. I wrote a little app, just a couple scripts to run on a Raspberry Pi. Tom, it's sitting in my basement. Okay, here's what an IoT newbie I am, and how much I avoided using a database on the Raspberry Pi. I put a camera on a Raspberry Pi and I pointed at my oil tank because I live in an old house that has an oil heater.
Okay.
And I have it take a picture once every 6 hours of the gauge on the oil tank and upload that picture. Yeah, you can tell the Rube Goldbergian.
It's clever. I think it's clever.
It is the Rube Goldbergian digital gauge. Uploads a picture into Azure, does the number recognition on where the number is in the gauge, and puts it into a Power BI chart, right? Nice. Does what I need it to do. What you're showing me, I could do this all with a 400-line script and store it into a little Zen database locally, and once every hour or so, push the latest positive record out to my Power BI dashboard now.
Absolutely, and you could even do all the recognition locally, and only bother to update it if it changed, for example.
I'm not saying, but it did cost me a couple of nickels here to do all that recognition using the AI services in the cloud. I'm not saying, but I'm just saying it cost a couple nickels to get that done, just to pull out numbers and for me to be lazy and not to go into my basement. But I love what you've written here. This is really neat to see, right? Database is literally the actual database call, 2-3 lines of code, all simple and real easy to get into.
And what you said reminded me of something. One of the things that we found gained some traction on this is that the whole idea of saving some money. So the more you can do locally, whether it's you don't want to send all the images upstream because you don't want to pay for the storage, or you lose connectivity occasionally. So the more you can do on the edge, the better. And the more powerful the database you have on the edge, the more you can do easily, right?
And think about all the processors that you have out there on the edge. If they're not busy, make them busy, because then you're paying for less cloud time.
Yeah, even this Jetson has 4 ARMs and 2 Denver CPUs. So it's amazing the amount of power that's out there now.
Are you kidding me? It's got 6 processors on that little board.
Yes, and the GPUs to go with it. So it's pretty amazing.
Okay, now I'm gonna have to get my hands on one of those boards and start setting up. Yes, Sean in the chat room is saying I need to refactor my oil tank vision project. Yes, I think I do, Sean, and I'm going to need to get a better camera this time. It's a great idea. Tom, you've inspired me here. I know what I'm doing for my December project now.
Excellent.
So
you productize that and make a fortune.
Nah. I just want to know when I need to reorder oil here, Tom. Come on.
Okay.
I'm not thinking that far ahead here. I'm just a guy on a camera on Twitch here. A Canon Mark VI camera, suggests Hugo. No, that's way too much camera, Hugo. Oh my goodness. Yeah, I'm not spending a couple $1,000s on a camera. So this is in an IoT device, right? So if we think about, right, embedded scaling, right, the next place that I would think that you would want to scale up to is either going to be a phone or a desktop application.
Okay. I do have a phone demo set up.
Okay. Sure. So let's take a look at that. Svava says yes, that would be a lot of camera. Yes, just to take a picture and have it mounted on a little tripod in my basement while Tom's getting set up here. I'm going to cut over. So nope. Okay, we can stay there. To have that big a camera sitting in my basement is going to be a waste, and I'd rather use that out taking pictures of what my kids' activities and travel and all that stuff. DevLead says, or buy an oil level sensor. Well, then you have to cut into the oil tank and put it in there and all kinds of stuff. I'm an IoT person. I'm a developer. I write code to solve problems. Let's see here. Oh, and thank you. Janescu has actually linked to the Jetson Nano developer kit for us in the chat room. Thank you so much. Yeah, very cool. All right. So that is which type of phone is that? It's an Android phone, but which one?
It's an Android. It's an old Moto that we picked up for next to nothing, and we get to play with here. And so we wrote an app using the Android SDK kit.
Okay.
And I'll show you the app first, and then if there's interest, we can look at the code that goes with it. So this is a very naive decibel meter.
Okay.
And what we're looking at here is every 1/10 of a second, it's sampling the microphone that's on the phone, calculating a decibel value and writing that to the database. And then the next 2 lines, it's doing queries to get the average over the last second and then the average over the last 10 seconds. And then the last line is just doing a count of the number of entries in the database of those values. And in this demo, I should mention that in the other one, we were using an interface that's sort of a NoSQL interface. We call it the btrieve interface. And in this demo, we're using our SQL side. So we'll get to look and see what that looks like. And in this demo, we're actually using an embedded SQL product that we have.
Okay, so different ways to interact, get the same interaction with a Zen database, 2 different facades, btrieve and SQL.
Yes.
Nice. Okay, as somebody who's a SQL first developer, I like that. Right? Now you're talking about a language that I know how to speak. Give me my select star from customers' interactions there. Okay. Hugo is suggesting that I'm avoiding saying that I'm frugal. No. No. Not at all. Gosh.
Oh my.
That is not what I'm saying at all. If you change the seals on an oil tank, it needs to be inspected. I don't want somebody to come out and inspecting my house just because I'm putting in a new gauge. So, RJF96 says, using a database feels like overkill. You could just use an array. Well, for the purposes of the demo, it shows off things here. Yes, it's in memory, but if you wanted to persist beyond just being in memory, you can't use an array.
That's correct. It's worth saying too that I think that if we run on Zen runs on ARM, it runs on Intel, AMD, it runs on multiple OSs. So one of the things you get, in addition to being able to persist it, is it's been very carefully designed so that the byte order in the structure of the bytes written in a record are the same regardless of the OS or the platform.
Oh.
So in the case of an array, that's going to be very specific to the language and the architecture. So with us, you could actually take the table that you wrote, the underlying file you wrote, and move it from that Jetson board running Ubuntu on ARM and bring it over to a Windows server run on an Intel and read that file in, and everything just works. There's no translation necessary at all. So that's another thing that the database layers is handling for you, and you don't have to worry about.
Okay, now you've got my interest peaked a little bit more there. I want to see a little bit more about the Android app that you have here, but that portability, being able to transport it across form factors, that's pretty interesting.
Yeah, that's once again, that's one of those things that we did, and we didn't realize what a big deal it is, but we talked to people, and people get really excited about that because it is. Now that ARM has taken off and Linux is doing well and Windows is still doing well, there's in Android, of course, there's iOS. We run on iOS. So
sure.
It could be a real cost to a company to try to support those multiple platforms if you don't choose your database management wisely.
Oh, I'm thinking about all the different ways that folks that are in the field need to synchronize their devices. Right, I've got an Android app here that I'm recording data. I'm taking pictures around a facility or wherever. Well, now I need to synchronize that back to the cloud. I need to synchronize that data back to my desktop. If it's in a Zen database, instead of piecemeal sending data somewhere, I can just take that whole database and just ship it.
Absolutely. So no ETL. So if you're using Zen everywhere, no ETL, and that buys you. One of the things that it buys you that may not be obvious is the security again, because every time you got to do ETL, you've got to de-encrypt, transform your data and then re-encrypt it. So there's a period of time there, even if it's in memory, where it's not encrypted. So if you're using us everywhere, it stays encrypted all the way through
the entire pipeline.
There's no concern there. That's exactly right. So as these, especially in the health industry, that's something they really worry about.
Oh my gosh. Real quick for the folks in the chat room, for some of our viewers, in case they're not familiar with the 3-letter acronym, ETL is extract, transform, and load, right?
That's what I think.
Okay. Right. So it's the action of taking data out of one database, putting it into a transportable format, and loading it into somewhere else.
Yes. I have a little, it might help. I'm sorry, I'm just going to scream through some graphics here. Here we go. So here's a slide we use a lot to show that, where you've got a sensor. Maybe it's writing the flat file. Maybe it's using Berkeley DB. That's another small database other than SQLite. Use, right? And maybe they've got some kind of larger gateway out there running MySQL. They're running SQLite on their phone. They've got Postgres running here, or perhaps SQL Server.
Oh my gosh, all these different database vendors and technologies and dialects, they all speak differently.
Yes. Yeah. So we like to say that's not Zen. So
no, that's a headache. That's what that is.
And then so we've got this very Zen view of the world, right? So here is that same graphic, but we've put Zen everywhere. And because of that, you don't have any of this ETL all the way through. And so not only do you reduce your security exposure a little bit, you also get a performance gain, because it obviously takes a few cycles to transform. To de-encrypt and re-encrypt does take a lot of cycles, right? And even the transformation takes a little bit.
Sure. Oh my gosh. And Adam TT222 in the chat room says not using SSIS, right? The SQL Server Integration Services packages. That feels good, says Adam. Yeah, you know what? It makes me think that everything is awesome when you can just take one database and you just move it around when you need to move data. Oh my gosh. All right, Tom. Yes, this makes a lot more sense to me. Hugo says data migration as a TLA, as a 3-letter acronym. Yeah, gosh, this is so much simpler when you're doing all that data migration. Okay, so this diagram makes a lot more sense to us. Can we go back to the source code for the Android app? Now, Android is of course written in Java, right? Or
yes.
Right, and it's got their specific libraries and things. And yes, there was a critique, of course, folks saying so many magic strings. Okay, about the strings, and it's a demo. Come on, it's easier to see the strings in a demo. My gosh, but fine. You want to refactor and write your code your way, chat room. So
I'm a database programmer. What can I say?
Absolutely, right? The acronyms. Okay, so looks like, so what do we have here? This is your main activity.
Right. So I'm not a Java programmer. I freely admit it. And this was my first Android app. So constructive criticism is of course always welcome. But what I've done here is for my own peace of mind, since I was much more comfortable in C++, I wrote the GUI part of it, the pretty stuff you see. I wrote that all in Java. And if you've written Android apps, I'm sure this all looks familiar to you. There's the onCreate, and then here's the thread that runs, doing the updates, sleeping 1/10 of a second. Once again, none of this is database stuff. Oh, here's where we open the media device. And if you want to, actually, this source code, if you'd like to get your hands on it and play with the embedded library on Android, if you go to our website, you can download our SDK for free, and this comes in that SDK. You don't need any sort of license to run this.
Nice. Do you have a link for that we can share with the folks in the chat room?
My best. Let's see. Well, you can always go to actian.com, and if you go to products and Zen embedded database. Honestly, I'm going to have to admit that I haven't done this on the new website. So at this point, I'm probably just wasting your time. Oh, here we go. Download. And from there, I wish you best of luck. SDKs.
Fantastic.
V14 evaluation. So here you go.
And there's the Android one.
Yep.
So that's esdactian.com/product/zen_PSQL. Nice. And there's all the different options. Right? Do I have that?
That's hard to figure out at all. Even I can do that.
It's amazing. I don't know my way around my own all the databases that we have with my employer. My gosh, so many of them. I'm going to share that link in the chat room there. There you go.
Perfect.
So that folks can get their hands on it if they want to take a look. And folks in the chat room are asking, what was Zen an acronym for again? Zero effort needed? No. It's pretty close.
If we use that, do we have to give you royalty?
No, not me. I think it's yeah.
It stands for, but I like yours. I like yours better. Whoever came up with that.
You hear that? This is Copper Beardy in the chat room there.
Thank you very much. 0 dBA embeddable nano footprint.
There you go.
Yeah.
0 dBA embeddable nano footprint.
I'm going to go visit our marketing guy after this.
Absolutely.
That's pretty clever.
Zero effort needed. Zero. Whatever. Okay, so we started seeing a little bit of the Android code, but we didn't get. We saw all the stuff to connect to the sensors and that kind of thing. the actual call into the database, though, right? You're using a SQL interface this time.
Yeah, so I just wanted to show you that flow, and here's where we're going to call us. So I've written some wrappers, get 1 second average. Well, let me back up a little bit. So here's where we get the value. So here's store and calculate, and that's the every 1/10 of a second value that I talked about. And here's the get 1 second average, the get 10 second average, and the get sample count. And that all corresponds to those 4 graphical elements that I meant that we saw earlier.
Okay.
Now go down here. As I mentioned, I'm not a Java programmer, so when I wrote this, I wrote it in C++, and Java has this wonderful ability to call JNI code, right? So
nice.
I wrote this in C++. I should say though that we do have a Java interface to the product, and you're always welcome to use that. Here's the JNI layer. So I'm trying not to give everybody a headache by scrolling too fast here.
But you're just putting together some simple SQL statements that you're executing on the.
So here's the store and calculate call. And if you're used to ODBC or in SQL, you're going to recognize this immediately. Here's the insert into the table. So I'm building up the SQL string, and then I'm doing an exec direct. And some people might immediately say, wow, an exec direct, that's terribly slow. Why didn't you prepare these and keep these around and do execs? Well, I didn't need to, because this is so fast that the database side of it just doesn't even really count. You could, of course, do that, but for these simpler queries, it wasn't necessary.
Yeah.
And here's the average. Good old SQL, right? There's the where clause. There's the average over the last, I think that's the last second.
Simple aggregate, right? We learned that back in high school.
That's right. Simple, here's the last 10 seconds. And then here's the select count. That's the number of elements that are in the table, right?
Yeah.
Then here is where I take care of the keeping the table from getting too big. So anything that's over 60 seconds old gets deleted out of the table.
Okay. There's a question in the chat room about some of the aggregates that you use. They're pretty standard ones, average, count. You probably have support also for min and max in the SQL dialect. The question here is there support for custom aggregate functions?
Well, I do not believe we do not support C++ or C code being put into the I don't even know how to say that. I'm not really a SQL programmer, but I have a helper over here off camera. She's over there shaking her head no. Okay. So the answer is no.
That's part of keep minimizing some of that bloat. If you don't, you can do some of that work when you get the data out if you need to do custom aggregation.
Yes, I should say, though, this is a good opportunity to say that the embedded SQL library has the exact same capability of our typical client server SQL interface. Our regular product that runs on like Windows Server or runs on Linux is a traditional SQL database, fully ANSI database. And this embedded library has I can tell you, it runs on the exact same code. So it has all the functionality. So if you wrote something using the SQL, say for the embedded library, and then you wanted to move that code or that knowledge that you've gained over to our normal product, it would just translate. There would be no new limited thing you had to deal with.
Okay, so now you've got me thinking that you've got a really cool portability story, right? We talked about it, instead of doing ETL and moving things from my Android application or from my IoT device into the cloud, where I've got a full-scale cloud strength server that's running Zen database. I could still use the exact same SQL dialect that I have in my Android device, lift that up, drop it into an Azure function or an AWS Lambda, and get the exact same performance against another Zen database that maybe is being replicated into. So just like you were showing us with PHP, putting data on a web page, I could do the exact same things. Now I've got the exact same logic and the exact same syntax across multiple platforms.
Yes, and here where I've done the delete, this could just as easily be me talking to a cloud instance of Zen, and this could be instead of just a simple delete, I could be inserting to a table up in the cloud as well. So I would keep a cache locally, and then when I had connectivity, I could move things up to the cloud with the exact same library, because the library actually has client server built in. It's just in this case, for this demo, we're pointing to a local instance instead of a cloud instance.
So let me come back and reinforce. There's a question here about having a .NET provider. There is now a .NET, a provider you can use with C#, with VB, that's .NET Standard.
Yes.
So to exactly your point, I can compile a .NET Standard library that references the Zen provider, and if I'm running on a Raspberry Pi with .NET Standard, or running a little .NET Core app on, like I'm doing with my Raspberry Pi, I can use that exact same library with the exact same select, insert, and delete statements, lift up, reuse that library now in my Azure Functions, and get the exact same interaction. I don't have to recompile or anything because it's .NET Standard. I'm referencing it, the exact same syntax everywhere. That portability is tremendously powerful.
Yeah, it's a great story, and my assistant again off camera. I'm really glad Linda's here. It's Linda Anderson. She said that the .NET that we're talking about is available on that same page that we were just at.
Terrific. Hugo says, "Thank you, Linda." There you go. Fuel Snable asks, "How do you deal with diverging schemas as you're versioning and improving your database?"
Well, I guess I can say this two ways. The product itself has a long history of being backward compatible. So we're never going to break you because you upgraded our product. We can still read tables that are 15, 20 years old.
Okay.
So we really, really believe that around here. Now, if you change your own schema,
yeah,
that's up to you. Right?
You've got to manage that interaction on your own.
I should say, though, that the btree side, which I mentioned earlier, it supports a type called JSON. And that's one of the beauties of JSON, right? And in the camera demo, that's what I used. If you look down at the table, it's really only got 3 fields. It's got a document ID, which is this auto increment integer, and it's got a clob, or what we call it. We have a special version of clob called JSON, and then it has a blob. And because of that, I can change willy-nilly what I want to store in that JSON.
Okay.
And it doesn't really matter. And that's the beauty of it, right? And we have the ability to query that JSON for you as well. So it's not just a simple clob.
So Fuel Snable is pointing out that they, at his organization, their organization, they have JSON schema hell, they're describing it, with apps with different views of the JSON schema out there. Yeah, good luck. That's right. That's not something a database provider is going to be able to manage, that schema inside of that JSON clob, that large character array that's hanging off the end, right, that you're able to use as expandable, no schema storage there.
Yeah, it's kind of like the attic, right? You shove things up there.
For me, it's my garage. Just throw stuff in there. Look,
I should say that what we've noticed internally people do is they'll create another table that has the thing that they care about and that every record's going to have.
Oh.
And then they index that, and then they have I mentioned the document ID, and then they have a table there. They have a row in that schema that points back to the main repository, if you will, that has the other JSON and the blob. And so it's kind of a wonderful way of having the performance benefits of a traditional record format of a fixed schema with indexing and all that, but still giving you the niceties of having JSON, where you don't necessarily have to have a complete understanding of your metadata or your schema at the very beginning.
And that feels almost like an old school data warehousing type of approach with, right, you set up a star schema. You know what? I need this extra little thing that I originally was putting in JSON. Just create another table that is foreign key, and here's that one field that I'm looking for.
Absolutely. And people don't think traditionally have thought of that in embedded apps, because that would mean, for most of them, that would mean a whole lot of work, especially if they're rolling their own files.
Yeah,
But when you have a fully functional traditional style database interface like we have, suddenly it becomes a lot simpler.
Yeah. So there's a couple questions here about database features. Let me just run down them here real quick. Hugo asks, did Tom say you can work with the JSON data? You can query the JSON data that's in that club hanging on a table.
Absolutely. And if we have time, and if you're interested, Jeff, we can take a look at some of that.
Sure. Let me hit one more question here. Fuel Snable asks about columnar storage. Is that supported? Yes, you have columns.
We don't. Our product itself doesn't store in a. I think when people say columnar, they're thinking of high performant databases, right? Where the data is not in the same file, that it's actually in separate files. No, Zen does not do that. Actian has product that does that. It's very fast at analytics. But no, we store it as a traditional file, but we certainly do have fixed schemas like you would expect from a traditional database. Yeah.
Nice. And there's a couple folks here in the chat room that are saying they're looking for similar features and in their database solutions, and Zen already has it for them. So yeah, there's definitely a subject. Flav Creation says this is a subject that they're looking into. Terrific. Well, there's a link we shared there earlier if you want to download the Zen database. There's the link again in the chat room if you want to download and check it out. Right? Did I see there was a free trial there?
Yes, there's a free trial for the embedded stuff, like what we've looked at on the Android here, is free, period. You can play with that all you want.
There you go.
The more traditional client server installs that ran on the Jetson, runs on Linux, runs on Windows, they have demo license, and you can always contact us if your demo license is going to expire and you need more time or you want to do some development. Yeah.
The question came up that I actually, Hugo, I asked about that just before we got on. I'll ask about it anyway. So there is a question here about, can it run in browser on WebAssembly inside of the browser using local storage? And we were saying no, it doesn't support that currently.
No. The demo I showed is JavaScript making calls into Apache on the Jetson, running PHP scripts on the server side.
Right. Yeah. That type of progressive web application where they can have local storage embedded in the browser. You've already got local storage there. That's supported by everything. To bring another database into the picture might be a little tricky to do at this point. But there's a product idea.
Yeah, no, Linda already wrote that down.
That's great. And Flav Creation says, I'm looking for something small that works with Java just for storing usernames and a dozen or two images per user, some minor integer and string data. There you go. This would
perfect.
Yeah.
Perfect. If you want to stay schemaless, I would say just use the JSON and the blobs. If you don't have that much data, that you're never going to see any performance problem with that.
Yeah. So there is a question about comparison to SQLite. I'm going to skip that because we did talk about that a little bit earlier. You can rewind, take a look back at our talk about how this compares to SQLite and the differences between the two. So real simple with Android here. Our friend Carrie, she's in the chat room. She wrote an article she just sent over to me about using Zen with Windows IoT Core. Let me share that in the chat room for folks. There it is. Over at Content Lab IO, folks can learn more about how she did Windows IoT Core. So that's Windows UWP. That's a neat looking article that she wrote for checking out Zen. Thank you so much for sharing that, Carrie. I appreciate that.
Yeah, I'm glad she did. I'd completely forgotten. We do support IoT as well.
Nice.
Win IoT as well.
But let's take that next step. We've been dancing around. All right, we've got the smaller devices, the IoT chip, the Android phone. Let's get to the cloud. What's this look like when we actually go and we take a look at getting into a real server, right? A server, right? Say it right, Jeff. Something that looks like a server.
we have an Amazon instance out here that I can connect to. And this is running on a Windows server, and this is running on IIS.
Okay.
So that shows that as well. And I'll look first at, I guess we'll look at that JSON querying, right? There was some interest in that JSON.
Yeah,
querying.
yeah.
So there's a thing called the document store.
Okay.
Right. And so this is what this is. And this is all built using some simple PHP scripts and sitting on top of a Zen database instance running out here. Some people worry about performance. So I just wanted to show this real quick. I'll grab one of these MP4 streams here. And if we look at the metadata really quick, it's just this MP4 out there. It's 1280 by 720. I picked this off the web. I'll swear in front of a judge that it's copyright free. So we're all good. And we'll just download it here. So in this case, we're streaming straight off that Amazon instance using PHP. And this blob is sitting right in the database.
Okay.
So, to me, the performance seems completely satisfactory.
And how big was the record? Can we see that?
Yeah, it's let's see. Where was I? I was this one. So what is that? 31 meg, 32 meg.
Nice.
And the reason that works is because PHP is using HTML5 to just return the parts that the browser says I need.
Mm.
And so it's reading from the database perhaps a meg at a time. But it performed extremely well.
Oh my gosh,
and
yes.
The reason I mentioned that also is because this leads into the querying. So in this case, in this particular PHP script, this document store PHP script that's running over on the server, he's doing a query that says just return me all the documents in the collection, or all
just
the
a select star. Okay.
Right.
There's a question in the chat room just asking to clarify the structure you have running here. This is using AWS. There's a Windows server deployed out there running
Yes.
IIS, and
Yes.
IIS is connecting and doing the query of the data.
That's right. So
Okay.
IIS has the PHP extension set up, and it's executing the PHP server-side scripts,
There you go.
just talking to the database. Absolutely. Okay, so what I've done here is now I've gone into this other demo
Mhm.
that's called the documents demo, but it's the same idea, and we're talking to a table out there, a database file, if you will, in this particular format, and I can just list all the documents. And as you can see, that's the exact same table that we looked at previously. But let's say I wanted to do some querying
Mm.
and only return certain things. Well, we can go do that as well. So
Okay.
here is the query. This is select star in the JSON query language. Now, if you're familiar with MongoDB at all, it should feel very familiar. So a JSON query that's empty returns you everything.
Sure.
But let's say I wanted only documents with this name. I'll copy this guy and put him in our little interactive query box and issue that query. And now we only get back that fellow.
The one record. Yeah.
And he is there. We have a query parser, we have a JSON parser and a JSON execution parser execution engine down in the database engine. So this is all happening server side. So the client is submitting this query saying, I want to run it on this table. That all happens on the server, and then we just return back the answer of that query. And it gets fancier, like we'll do one fancier one here. So this is, I want the name that's in this set of names. So you can imagine what's going to happen here, I bet.
Sure, we should get those two back.
Absolutely.
But
And there's the two we get back.
right, the interest here is this is querying that JSON field. This is going through and looking at the fields inside of it.
Right. So we'll look at the JSON here for this guy real quick. It is running that query against the JSON of every record in that collection or in that table. And here's the name field, and here's the value, and that value satisfied the query.
Oh my gosh. So, all right, Fuel Snable has a size and performance type question.
Okay.
Fuel Snable says, I have petabytes of compressed JSON documents with a chaotic schema at work. Is that a scale Zen is meant to handle as well? What are the storage options, as petabytes cost quite a lot to store?
All right. Well, I'll be completely honest with you. I don't believe that. It depends on your response requirements, right? I mean, if this is the kind of thing you're going to want to report at night, and you don't really need a any kind of real-time response, I think we would be just fine. If you needed a real-time response, kind of a transactional atmosphere there, you're going to have to look at something, either one of our more powerful products or perhaps MongoDB. Because MongoDB is more designed to scale out well, right?
Sure.
Whereas I believe they would be overkill for the kind of environments we want to run in, and we're not really up to running in the kind of environments they can run in at the large scale.
Sure. The goal here is to be able to run with a smaller footprint, and you're not necessarily looking at giant scale like that.
That's correct. Now, we did run this against. We downloaded, I think there's a public domain version of the IMDb database.
Oh, yeah.
And we did run some queries against that. And I can't give you any numbers. I'm not prepared. I don't have a chart for that. But we were very pleasantly surprised with it. And I do believe it is because it all happens inside the server. It's a very, very, very fast process. And the parser is actually written in C. The parser and the executor is only a few hundred lines. It's very fast.
Nice. Hugo suggests another great use case. Copy the data file over to a number-crunching, CPU-laden report generator. Yeah. Oh my gosh, yes.
Sure.
If you've got all your little devices, if you've got Windows applications, you've got Android applications that have Zen databases they're storing locally, synchronize them out to, some big report generator machine and let it crunch through it all. Oh my gosh, yes.
Yeah.
Okay. So, I mean, this is really cool how you're able to search through and interact with the JSON, and this is running, is this a big machine that's running out there on AWS, or do you have it running on something
I think it's
more modest?
It's an Amazon small instance, so what is that, 2 processors maybe?
Okay.
I don't know, 4 gig of RAM. I can't even remember. It's been out there humming along for so long, we've all kind of forgotten about what it was.
Hang on. So 4 gig of RAM. Just to call back to the Jetson device. The Jetson device had 16.
Oh yeah, the Jetson device is much more powerful than this was on its right now. Yeah. The Jetson device actually spends, in that little demo I ran, each update was 200 milliseconds, and I have some numbers on that on the status. It was spending over 100 of those milliseconds doing the facial recognition. Everything else was basically free.
Oh my gosh. Okay. Wow. The database performance is really great. Fuel Snable asks, can you store the Zen database files on cheaper storage like S3?
Sure. They are just file system, OS file system files, just like any other file. So we can get at it. We can run off a thumb drive. I mean, we do not care. We're not that low level. It doesn't matter to us.
It really says something about the portability of the database files and the database structure, that it's files and all the OSs know what files are.
Exactly.
Very cool. And I'm just reading through some more of the chat room here. Just beware of IOPS if your builder restricted on that metric. True. Yeah. That could definitely be an issue for folks. Another person here, Boom Boom, says, I have dedicated on-demand report generators for their project at work. That's not a bad architecture either. When you start pushing around database files and you're going to deploy, to have it sit there on an on-demand report generator, spin up because new files arrived. Oh my gosh.
That's a great question. As a matter of fact, one of the products we introduced a couple years ago is a dedicated SQL report engine, and he's designed for that very thing. You spin him up, or he sits on another machine, and he's a SQL engine built on top of a cache engine. And so you point him at your main database, and you run your queries, which are by, if not completely, they're by and large read only. And it runs just as fast as it would if it were local, if you have any kind of network speed at all. And because people had that exact desire, they didn't want to slow down their main server, and they only needed that report generator to be up certain times. So that's been a pretty big win for us.
Oh yeah. So along those lines, Hugo goes on to ask, does Zen run in memory as well, or is it strictly with file system?
Well, it's both. It'll take over as much of the machine as you tell it to take over, as far as RAM's concerned. By default, I believe we take up to 60% of the RAM.
Okay.
That's configurable, and so everything you do is cached. But if you run out of RAM, we will start moving things to disk.
Okay.
If you do transactions and you complete transactions, we'll write them to disk for you, because that's part of the guarantee, the contract we have with you. So it's both. It's not purely one or the other.
Nice. Tune it as needed.
Yes.
Yeah, Hugo says that's very nice. That's an even better solution. Cool. Glad we answered your question, Hugo. DevLead asks, can you pass the database as a stream to the engine? Then you'd be able to use memory streams, blob streams, file streams, those architectures that we have in C# and .NET to be able to pass around files as a byte array. Can you load into the engine?
What I would do in that case is, and we do have a customer that wants to do that. I think it fits into the question. They want to move Docker images around.
Oh.
And they're so concerned about their IP that they want to send encrypted Docker images up and down. So what we've suggested to them is they have a very simple SQL server. I mean, I said SQL server. Okay, that's it. I'm fired. A Zen server on the box, and in that server contains encrypted Docker images. So you send the whole Docker image down, and when you want to run them, there's just enough code on that server to pull that out, de-encrypt it, kick off the Docker image, and then immediately that Docker engine goes away. So there's very little exposure. So I don't know if that answers the question or not.
That's and DevLead is thinking more at the C# API level, but I'm going to go a little bit further into what you're talking about, Tom. That feels like they're building an encrypted end-to-end Docker client and registry.
Yes.
Which, right, there's a whole nother thing there about having encrypted packages, not just Docker packages. I'm thinking packages that folks might use with Node.js or Python or PHP or NuGet. Have that end-to-end encrypted interaction from a registry, which is really, like you're suggesting, it's just a database. A registry is. And your client is, right, I mean, you've already got clients, whether it's NPM or pip or NuGet, that you're using or the Docker client to connect back and forth to just wrap that with a client call through the Zen, a Zen request out to that central registry. That's pretty impressive.
Yeah, I mean, we replace all of that, and we're encrypted, right? So you don't need FTP or SSTP or PIP or whatever. You just talk to us.
Yeah, very cool. So we have a friend who goes by Robert Tables in the chat room. We've said containers enough here. They're summoning Robert Tables to join us. He's a fan of containers. So DevLead was thinking more at the C# API level. So if we do have locally stored all of our content for a database, and DevLead, let me know if I'm explaining this correctly. Is there a way for us to connect it to the engine and load, using our C# APIs, the contents of the database? That I don't think that's something that
I have to admit my weakness in C# is probably showing now.
It's okay.
We do. I mean, are we talking about moving the entire database instance across the wire? Or are we talking just simple client server?
Reading the question again, can you pass the database as a stream? So I would think the database contents, not a typical select star from or insert into record, right? Those things, it's clear. Yeah, you can do that.
Yeah.
But being able to connect to just the engine and say, here's new files that I want to consume, I want you to start working with.
No, I think the only way we would handle that is in the more traditional client server, where you have you're running on your phone or your desktop or whatever, and you, by simply changing your connect string, you could connect to another database on another instance.
I have two connections, and
yeah, that works all day long.
Okay.
But that's the way you'd have to do it.
Okay. And we've talked a little bit about, and I don't know if you have a demo ready for this, but we have talked a little bit about using the same database files, the same database content, whether it's on the IoT, it's on Android or a mobile device, and out in the cloud. What does that procedure look like if I want to take my files because it's saved to disk, and I want to now migrate and synchronize those files to the cloud database? So we're here on the cloud database. What's that look like?
I'm sorry, I'm not set up for that, but it is literally just a file copy.
Nice.
The closest I could show you is I have a setup where I can talk to that Jetson box we were looking at, and I can talk to it from a SQL install we have on a Windows box, but and show you how that would work. But I'm not prepared to move a file currently, unfortunately, off that Jetson box and move it. But it is really just a file copy.
We kind of went off script there. That's okay. But a file copy out and mount that as another database, and at that point you've got it on the same server, and you can do the same server interactions.
You'd FTP it or copy it to a thumb drive, carry it over to the other box. You don't even have to take it off the thumb drive. You could just tell Btrieve, I want to open a file up that's in d:/whatever, and it would see the file. And you could run the same scripts that you were running on your other box on that box, or a new set of scripts. The schema and the data completely preserved.
Nice. Oh, that's great to see. So, chat room's gone quiet on me for all of a sudden. They were all asking all kinds of great features, questions here, and they've gone quiet. Are we still there, chat room? Let me know. My gosh. There we go. The hamster wheels are all spinning, says Hugo. Yeah, we've got them thinking. So, very cool. All right.
We could look at some source.
So can we take a look at what the PHP commands look like to interact with?
Sure. So here's a really silly demo. It was the first one I ever wrote. And it's asking a database to find the square and the square root of a number. So there, we have this hypothetical machine that can't do squares and square roots, right? So we solve it by putting it in the table. and there's actually a very boring story from an old programmer that'll tell you why this idea actually was used at one time. But what we're doing here is we create a table, we populate it with the square and the square root of the number, all the integers 1 through 255.
Okay.
We do the query, and then we print out the results. And this is all using PHP. So as you saw, I just did that. I'll put another number in here. Bam. Okay.
Sure.
So we'll look at the source code real quick. Now, before I've been showing you things that were wrapped in something called collections and documents.
Sure.
That's a wrapper that's like one level higher than the base API. And so we're going to be looking at the base API here. So here's the file. This is something we call a URI, and this is great for when you want to write a program and you want to be able to change what server you're pointing at. So if I wanted to run this as a client server, I would literally just change localhost to be, Tom's desktop or something.
Sure. Someplace else on the network.
This could also be /user /Tom / square roots, or C:/, right? I mean, it literally could be anything. We scroll down here. This is all PHP kind of parsing, right? I'm getting the value off the command line. And then here's the client. So we create a Btrieve client. This is the identifier, so that if I want to do any kind of debugging or performance analysis on the server, I'll have that ID, and then I can refer to that ID when I'm looking at the performance on the server side.
Okay, that's a client ID. Is that something you make up, or it's issued to you by the server?
I make that up, and then the server tacks a little extra on it, and then it keeps track of me, and so it knows I'm talking to it as opposed to somebody else.
Okay.
And then I create a file attributes object, because remember, I'm going to create a file. So we create a file attributes object. This is going to be the record length. I set the record length, and then I create the file. And I'm saying here that I don't want to overwrite the file if it already exists. Okay?
Sure. Okay.
So there's the file create. So at this point, we've created a file with that record. Now you notice there's no schema. And that's because Btrieve, the NoSQL side of the product, if you will, is schemaless, in that it doesn't have to have a schema. I'm just saying I have records that are this long. That's it. And those can be variable length, which they are in the case of clobs and blobs. Now I'm going to create a file instance, and I'm going to open the file. So you can see I pointed at the client instance, and I'm opening the file with that file name we mentioned.
Yep. Yeah.
And I'm going to open it normally. And scroll on down here. This is where I'm writing those values in that I mentioned, the square and the square root.
To initialize that table.
Right, initialize that table. So there's the record. And then here's my file record create with the record.
Yeah.
And I'm going to index this, because remember, you're going to give me a number and I'm going to look that up. So I don't want to do table scans. So I'm going to put an index on this table. So we call those keys. So I create a key segment, because an index can have multiple key segments. The field, that the offset and the length, these are 1-byte integers, because I'm only doing 1 through 255.
Sure.
It's an integer. So I set the key segment to be that, and then I say, okay, I'm going to create an index attribute. It's gonna look kind of long-winded here, but stay with me, it'll be clear. So we created a key segment that was a 1-byte integer. Now we're saying we want an index on that key. So we add that key segment to the index, and then we create the index. And so here's file, that file I opened earlier, index create with these attributes, and I want to call that index number 1.
And then you're checking to make sure that there's no errors in the creation.
That's
and that
right.
assert next. Nice.
That's right. So at this point, we've populated the table and we've created an index on it.
Very cool.
And then I want to look up what you gave me. So here's the integer value passed in. I create a buffer for the record, a buffer for the key. I build that up, and then here's the record retrieve on that file. So I want to get the record where it's equal. We support all the normal things, greater than, less than. And on this index, here's the key and here's the record. Then I unpack the record using PHP. This is all PHP specific. I encode it as JSON, because I'm going to return it back to Apache and return it, in this case, IIS, and then return it back to the script as JSON.
Sure.
And then at the end, if I've asked to delete the file when I'm done, there's the file delete. So that's the whole shooting match for using the lower level Btrieve interface.
Nice. Oh, that's great stuff. So, we've seen how to use Btrieve. We've seen how to use SQL with Zen, IoT, Android, and now all the way up in the cloud. A lot of flexibility here. And demos available, free access if folks want to use this inside their mobile applications. Look at how positive. Look at that. 100% perfect sentiment right there. Thank you so much, chat room. I'm glad you're enjoying what we're talking about here around the Zen database. And folks can learn more all about this at Actian.com, right?
Yes, absolutely.
Terrific. WorldWake says database talk, and they've been studying Neo4j, a graph database. Are there graph database features available for Zen as a side product, perhaps?
No. The only thing I can say that we're added lately that's kind of cool is we're adding time series support.
Okay.
But not graph yet, no.
Okay.
But we do have other products. If we have some products that are really, really high performant, those kind of things. If that would interest them, they should check that out while they're at the web page. Yeah,
right. Different tools for different things, different solutions. Graph database has its place, and you've got down great access for NoSQL structured and columnar based data. Very cool. Libraries for so many languages and platforms. Hugo really likes seeing that. folks have really enjoyed our discussion here today. Terrific.
I should say that with the languages, when we designed the Btrieve interface that we just went through, we were very careful to make sure that it was consumable by SWIG. And if you've never heard of SWIG,
no, I haven't.
It's a simplified wrapper interface generator, right? Somebody really wanted to say SWIG, but it came out of one of the national labs 10, 20 years ago, right? So these guys had a problem, which was they had these cool APIs that they'd written in C, but they were tired of writing in C. So what do? Well, they figured out that a well-written include file defines an entire API.
Oh, yeah, sure.
Feed that into this SWIG tool, and you say, I want to generate Python, or I want to generate Perl. It'll automatically generate all the wrappers for you. So when we wrote the Btrieve interface, the newer one, we call it Btrieve 2, we were very careful to do that. So that's why we're able to support Perl and PHP and Python and Java pretty simply. And the point I'm getting to is that if you like, for example, Go, right? There's some people who are just crazy about the Go language.
Sure.
Don't look out there and go, oh, they don't support Go. If you download our SDK, the SWIG file is there and some simple instructions how to generate it. So if you like Ruby, you like Go, whatever.
Nice. Okay.
Just go grab those, take an afternoon and build yourself the interface of your dreams for the language of your dreams, right? I mean, that's the idea. Absolutely. Now,
would it make sense to reach out to someone at Actian support to coordinate if we generated API for Go or some other really esoteric language? Go's not esoteric, but something that isn't currently supported, right? VB2 we generated an API for. I don't know. And would it make sense to coordinate if we wanted to say, look, I want to submit this to something that my VB2 community can share? I don't know. I'm picking on Visual Basic version 2 here, but to be able to say, hey, I want to release. I used your tools. I generated the API for this. I'd like to release this and coordinate and make sure that we stay in sync. Is that something that it would make sense to partner with Actian so that they can get good support when new features come along?
I'm a developer, so I want to say absolutely positively that sounds great. We love that. And I know we have blogs, and Linda is actually the support manager. So I'm over looking at her, waiting for some sort of answer. What would they do? Would they just call support or somebody and say, hey, I've done this. Do you guys want access to it, or do you want to talk about it?
Right.
Probably post it on the community.
Oh, we have a community. We
Fantastic.
have a web just for that sort of thing. So yeah, absolutely. We'd love to hear about it.
Yeah, all right. So, oh gosh, there's a suggestion even if there was a FoxPro interface. FoxPro, I don't know. You're kind of crossing the streams there to say you want a FoxPro interface, right?
Yeah, you know what? Go to the SWIG page. If you Google for SWIG, you'll either get beer drinking or the right page, and they may have one. Who knows?
Kate's asks, in terms of the underlying file system, here's a good performance question. Are 10,000 RPM drives feasible, or should they look to keep everything solid state? I think solid state's the way to go these days.
Well, I mean, once again, it's always about what performance do you need and what's your budget, right? I mean, yeah. That's the only answer I have. Now, in the database world, I mean, we support if you use transactions and you ask for logging, which is an option, we do support putting the logs on a different drive than the data. So in that case, I might put the logs on an SSD. Mm-hmm. And then if I have a lot of data, I might buy some huge old slow 1700 or 5400 drive and just shove it all out on that, right? And take the money and go take the kids to the movie or something, right? I mean,
sure.
Right.
Sure.
It all depends on what you want to do.
Sure. Especially when we're talking about the smaller, right, the edge devices, put it on the solid state, the SD chip that might be riding on one of those, the M.2, whatever, NVMe that's inside that device. And then, yeah, when you do your sync, when you need to ship it somewhere, I agree with you. You've got a big cabinet somewhere loaded up with those spinning Rust drives and keep it on cold storage out there.
It's
right?
a great question because, like you said, the Jetson just has an SD, right? So it's a perfect example of doing some analytics and storage locally and then just shipping what you need to upstream.
Yeah. So, really good questions here. Thank you so much. Oh, Hugo linked to swig.org for us.
Oh, thank you.
Thanks so much. Is that it? Yep. Simplified wrapper and interface generator. Thank you, Hugo. There you go. And I can see the website is fresh out of 1994. Oh my goodness.
Well, now you have to be careful because sometimes Google will send you to Swig 2.0, right? And they're up to 4.0, so you got to kind of be careful where you go. But
Oh,
yeah,
absolutely.
I don't think they spend a lot of time worrying about their web design.
I like Tom. I like to say we're developers. We don't do web design. We just put data out there so other developers can read, and it's in black and white like the screen we see here. Oh my goodness.
Yes.
That's terrific. All right. Well, I don't think we had. I think that was the end of the demos we wanted to show. Is there anything else we want to call out to here? We want to make sure that folks know about regarding Actian.
I don't know. I don't think so. I think that's all I have for you today.
Yeah. You know what? You and I, we've been around this industry for a while. There's a question that came in from somebody who's in their mid-20s asking, what do you think about, right, as experts that have been around this industry for a little bit, the question is, what do we think of coding boot camps to make a career change in your 20s? You know what, Tom, I look at the only, I don't know about you, but the only thing that I've seen in this industry is there's constantly change. And you need to learn the next technology in order to advance your career. I've had to learn new technologies between my 20s, my 30s, and now into my 40s. You need to be able to shift and go with them. So if you're taking a coding boot camp in your 20s, that's great. But and you'll find a job in your 20s. But when you get into your 30s, you're going to have to learn the new technology that comes out then.
Absolutely. I think it's a great idea. I mean, if you've got a knack for coding, the only thing that changes is the language and are we doing web design or are we doing back end? You go through phases and languages changes, but the group of skills you get for how do I attack this problem and do I enjoy solving problems? If that never leaves you, you just, like you said, you just got to learn whatever the language of the decade is, and you're good.
And then you have products that are going to help you along the way that are going to try and keep things concept compatible, like Actian Zen, like some of the operating systems we use, the programming languages we use. They're going to try to advance and keep up features with whatever that next thing is. I make this joke, Tom, and tell me if it's completely out of line. I'm not going to use a VR headset until I can put Excel spreadsheets virtually on the walls everywhere and do my accounting. You know what I'm saying? I need to take my accounting to VR and then it's ready for me. Same types of thing.
That would be awesome.
That's right. What is the language of this decade? I don't know. The programming language of this decade feels like we're in JavaScript. Node is right, and there's Node APIs for Zen as well, right?
For JavaScript?
Yeah.
Well, we haven't done it, but I do know that Swig supports Node.js, so server side should work.
Yeah.
I haven't done it personally. I tell you what, I just learned JavaScript maybe a year ago. I just started writing in JavaScript because I wanted to do some cool stuff in web pages, and I found this 30-year-old engineer and said, help. And he said, you need to learn JavaScript.
There you go.
That's what I did. So that's a good example of what you were talking about before.
Yeah. Got to learn something new.
A lot of people really like Python for server-side scripting.
Absolutely.
And I've really fallen in love with it. It's you can do so much with so little. It's very comfortable.
I'm almost tempted to try Python. Really big with Jupyter notebooks, right? We can run a notebook inside the browser. I'd be curious if I could take a Jupyter notebook and almost generate on-the-fly reports from my Zen database.
Why not? I haven't done it. I don't know why it wouldn't work.
Yeah. So, JavaScript is of many colors, no question. Yeah, absolutely. What's the language of the next decade? People are asking. Well, we can talk about that another time. I'm not sure. Python, like you're saying, is
a complete guess. So who knows?
Exactly, right? I even work with people that write languages, and they're not even thinking about the language of the next decade. That's an interesting question.
I think those things have a way of figuring themselves out, right?
Sure.
Yeah.
Sure. Someone's holding out here for a COBOL resurgence. Now that's just wrong.
I was wondering when COBOL would come up. I almost said it, but I bit my lip.
Nah, there you go. Well, this is great, Tom. Thank you so much for sharing. Let me go back here to the 2-up screen of us. I really appreciate learning a lot here about the Zen database. And there was comments earlier about I should rewrite my little oil tank monitor so that it's using a Zen database and be able to slim that down. You know, I've wanted to spend some time learning Python, and I would love to, if you could share a little bit of the Python script that you had there that worked with the Zen database. I'd love to explore that a little bit further on stream in December, and maybe see what I can do to make that work and refactor my little. And folks, if you're out there, you can find in the archive on the YouTube channel the little oil tank measurement project that we put together. That feels like the right direction for me to go with that project. So I can figure that out for this winter. I actually had that at one point ready to trigger a phone call to my oil company. How weird would this be? Sending a phone call and routing it through text-to-speech recognizer so that I could literally have a computer voice say to the oil company, Jeff needs an oil shipment. And
like, you're braver than I am. You might end up with 5 trucks lined up outside.
That'd be terrible, but maybe a way to go. So I might revisit Zen here in December when I get on the other side. November is a little bit crazy for me here. So okay. Thank you so much. Once again, I really appreciate you joining us. Friends, make sure you check out Actian at actian.com. And we had a link for the SDK there earlier. Let me share that. And our friend Carrie Payette had that article. There's the link for that about using Zen with Windows IoT. Very cool.
Well, Linda just tapped me on the shoulder and said that we have a simple Python example in the blog.
Oh, terrific.
I do, but I'm not signed up
to
share it.
So, interesting tidbit. We can't send you a link. I'm sorry.
Tell you what, if you're watching on YouTube, check the description area below. We're going to copy that, the link that we have from Linda. We'll copy that into the description area below so that you can click through and learn more about that. If you're here on Twitch and you're watching live, we'll get that over to you. But it's on the Actian blog. What's the URL for the Actian blog? Is it just blog.actian.com?
I wish. Where are we going, Linda? Blog. Hey, yeah. If you go to actian.com, there's a blog on the top. A blog link on the top center-ish.
There we go. Data at Work, the official Actian blog.
There you go. And then
there's the link in the chat room for you.
Here, she's saying search.
And put Zen Python ODBC blog.
Python ODBC blog.
Mm-hmm. There we go.
Hey. All right, now we're going to watch me try to figure out how to share this link with you guys.
Yep, copy, and then inside of Skype, if you mouse over it on the right side of Skype, at the bottom there is a little text bubble.
Oh, yes. And I can just paste it here.
Paste it there. I will copy and share that link over to Twitch, and I'll make sure that link gets into the description here on YouTube as well.
Thank you, Linda.
There we go. There's a link to that about using with Python and ODBC. Very cool. All right, Tom. So when we wrap up here, I like to look for somebody else that's streaming, because this really is kind of like a talk show, right? Kind of like talk radio, and I'd like to look for some other folks that are doing some programming, talking about tech content that we can transition, we can send folks over to that are doing other cool stuff here on Twitch.
Okay.
Yeah, thank you very much, Linda and Tom from Cary there in the chat room. Hugo says, thanks so much for the great information about the cool product. So much to think about now. Absolutely. So this is on Twitch. We call this a raid. We're going to send everybody over to the next channel so they can visit, and we'll do a transition just like you hear on Talk Radio. So, folks, if you're out there in the chat room and you're a subscriber, copy that first line of text that the bot just posted out there. If you're not a subscriber, copy the second line of text, and we're going to go see Matthew D. Groves. Matt's another one of the live coders, just like me, who writes code here on Twitch. And Matt is working on... he's doing some event sourcing work and experimenting with the CQRS architecture. So get ready to go over and visit Matt. Thanks so much to everybody for tuning in. This video, like all my other videos, will be available over there on the YouTube channel, youtube.com/C#Fritz. There it is down there in the corner. And get ready to go see... Let me make sure I get his name spelled right here. There we go. All right, friends. Take care, and we will see you tomorrow. We'll be writing some code again. Alrighty. Bye-bye.